All right, let's talk about a problem that I'm betting a lot of you are running into right now. You've got a fantastic LLM fine-tuning experiment working, it's getting great results, but now you have to scale it. How do you take that success and roll it out across an entire organization without, everything catching on fire? Today, we're going from that solo lab notebook to a full-blown automated AI factory.
So let's frame this up. It's really a tale of two worlds, right? You've got the lab and you've got the factory. In the lab, a single engineer can move at the speed of light. They're iterating in a notebook, things are working, it feels amazing. But that speed is built on a fragile foundation. The scripts are messy, the datasets aren't versioned, and that's fine for one person. But when you try to scale that to the factory with 10+ teams and hundreds of models, that whole approach just completely falls apart.
Okay, so here's our game plan for getting from that lab to the factory. We'll start by looking at that solo experiment and why it's a trap. Then we'll see what happens when scale breaks everything. After that, we'll lay out a proper blueprint for shared infrastructure, build out an automated factory on top of it, set some rules for moving fast safely, and finally see how this all comes together as a mature platform.
Right, so Section 1, the solo experiment. You know that feeling, right? You get your first fine-tuning run to work in a notebook, and it feels like actual magic. But, and this is a big but, that magic is kind of an illusion. It's hiding a mountain of technical debt, hard-coded file paths, data files that only exist on your laptop. The whole thing is basically impossible for anyone else to replicate, let alone build upon.
And then, of course, this happens. Your little experiment is a smashing success. Suddenly, everyone wants in. The support team is knocking on your door saying, "Hey, can we get a model for our tickets?" The sales team wants one for their call transcripts. Compliance needs one for document review. What could possibly go wrong?
Well, pretty much everything. Without a system, success spirals into a total nightmare. Teams are literally stepping on each other's toes. One team pushes a new model and, whoops, they've just overwritten the production artifact for a completely different team, causing a major outage. Training runs that worked last week suddenly don't. Nobody knows who owns what. It's just complete chaos.
So how do we climb out of this mess? It starts with a huge mindset shift. We have to stop treating fine-tuning like a bunch of one-off science fair projects and start treating it like a real, professional software project. It needs to be handled like shared infrastructure. And every good piece of infrastructure starts with a solid blueprint.
And this right here, this is your blueprint for sanity, a monorepo. Now you might be thinking it's just a bunch of folders, but it's so much more than that. This is about creating a single source of truth for your entire AI ecosystem. Notice how everything has its place. Base models live here, datasets live there, and team-specific adapters are separate. This structure is what lets us establish clear ownership and make every single thing we do reproducible. Now, let's zoom in on one of those folders, the datasets. Every single dataset needs what I call a contract. It's basically this little metadata file, but it's mission critical. It tells you exactly who owns the data, what version it is, and if it's even approved for production use. So now, if the support team wants to change their data schema, they have to bump that version number. No more silently breaking another team's model.
And we apply that exact same discipline to our fine-tuned models, especially those LoRa adapters. We're done with file names like model_final_v2_final_final. We need a real system. We need semantic versioning. A name like LoRa support v2.1.0 tells you everything you need to know. A major version bump? Okay, that's a breaking change. Minor? A quality improvement. Patch? Just a small bug fix. It's clarity.
Now, if you take only one thing away from this whole explainer, make it this. Never overwrite artifacts. Immutability is the absolute bedrock of this entire system. Every single trained model, every single data set gets a unique permanent ID. Why? Because this is your get-out-of-jail-free card. This is what makes safe, instant rollbacks even possible.
Okay, blueprint in hand, it's time to build the factory itself. And we're going to do that by creating a fine-tuning assembly line, borrowing some battle-tested ideas from the software world, continuous integration and continuous delivery, or CI/CD. So picture this, a developer on the support team merges a code change. That single action kicks off this whole automated pipeline. First, we validate their data. Is the schema right? Is the quality good? Then, we kick off the actual training job on our GPU cluster. Then, and this is critical, we automatically evaluate the new model against a standardized golden dataset. If its performance drops, the pipeline fails. Right there. No bad model gets past this point.
But, automation can't catch everything. We're dealing with powerful AI here. So, for that final step, we still need a human in the loop. This is our final quality gate. The model passed all the automated tests, but now a real person, like the ML lead or someone from compliance, has to give it the final sign-off. And the best part? That approval is stored as metadata. There is a permanent, auditable record of who approved what and when.
All right, let's talk about governance. I know, that word probably makes you think of slow, painful meetings and endless paperwork. But we're going to flip that on its head. Good governance isn't about slowing people down. It's about creating automated guardrails so your teams can actually move faster because they can do it safely.
And here's the entire philosophy in 4 words. Automate checks, not docs. Seriously, forget the 100-page PDF that sits on a shared drive unread. The best rules are the ones you can't break, because the system itself enforces them for you. It's governance that works, because you don't even have to think about it.
So what does that actually look like? Well, the system can just say, nope, you can't deploy this model to production without an evaluation score, or, sorry, that dataset isn't on the approved list. It can automatically scan for PII and just block the training run if it finds any. It's like having a hyper-vigilant robot co-pilot watching over every single developer, keeping them safe.
Okay, let's run a fire drill. The worst has happened. That shiny new support model, version 2.1.0, just got pushed to production, and the monitoring dashboards are lighting up like a Christmas tree. Something is very, very wrong. In the old world, this would be total panic.
But here's the beautiful part. In this new world, it's a non-event. Because everything is versioned and immutable, the fix is instant. You just change one line of config to point the production service back to the last known good version, 1.4.2. Done. The incident is resolved in seconds. No frantic debugging, no emergency retraining. That is resilience by design.
And just like that, by putting all of these pieces together, the structured repo, the strict versioning, the automated pipeline, and the baked-in governance, we've done it. We have successfully transformed that fragile, chaotic collection of experiments into a genuine, reliable, and scalable AI platform.
And now that we have a real platform, we can start managing it like one. We can look at key metrics that tell us about the health of our whole factory. We can see how many adapters each team is shipping, or how long it takes to get from an idea to production. But my favorite metric is retraining frequency. If you see a team retraining their model every single day, that's not a sign of productivity. It's a huge red flag that something is unstable in their data, and you can proactively go help them.
So I'll leave you with this final thought. We pour all of this incredible energy into making our AI models smarter and smarter every day. But are we putting that same level of energy and sophistication into the infrastructure that supports them? Because at the end of the day, a brilliant model running on a fragile, chaotic system isn't going to get you very far. True, sustainable success comes when your infrastructure is just as smart as the AI it supports.